Hello academic stars around the world. Welcome back to Caltex Academy. Today we're still continuing with our complex numbers series and we're looking at operations on complex numbers. The following arithmetic operations of addition, subtraction, multiplication, and division can be performed on complex numbers just like other parts of math. So we have to know that it is just normal way of doing our math operation on complex numbers. So the first one here, we're going to look at addition and subtraction of complex numbers. Now we need to know this simple rule here for us to start looking at some example. And it says, when adding or subtracting complex numbers, the real parts are added or subtracted together depending on the sign. If you're adding, meaning you add the real parts together, and if you're subtracting, you also subtract the real parts. And the imaginary parts are also treated separately. So the same applies to the real part and imaginary part. You work them separately. With all this said, we can now move on and take a look at our first example, which contains two parts here. And the first part of this example is saying, if Z1 is given by 3 plus 2i and Z2 is given by 4 minus 4i, work out part A, Z1 plus Z2, and part B, Z1 minus Z2. So feel free, if you understood what we meant here, to pause the video and work it on your own to see what answer you get. All right, if I've done it, thank you. Now let's do together and we'll take a look at how this number is worked out. So we have part A of the questions that is requesting us to get Z1 plus Z2. When we're given in terms of Z1, Z2, so we have to write our Z1 and Z2 in the left-hand side, and the right-hand side is where we replace them by the given complex numbers here. So we know our Z1 is 3 plus 2i. And we're adding is this addition here. So we say plus, or maybe let's use a different color for this, such that it looks a little bit unique. So we have this plus here so that it does not interfere with what we had there earlier on. And the second one is Z2 with complex numbers of 4 minus 4i. And from what has been given to us earlier on here, we said we treat these parts separately. Now let's collect like terms together, bringing these real parts together, where we have 3 as the first one, and this one comes together with the sign, and that is positive. So we have 3 plus 4. And the next one is the imaginary part. Let's continue separating them with these two different colors. So the imaginary part from this side here is positive, and is this positive here? Positive 2i. And the second one is negative 4i. Again, if you want to see this clearly, you will have to create a bracket and factor out I. So it is advisable to factor I in this part here. So what I mean here is, like, we can say plus, and we create a bracket here. And if you factor out our I would be here, and we're left here with only 2 inside here, and also minus 4. Now, this part will add itself, that is the real part, and we have 7. So let's simplify what is in the bracket, and we have our 7. So this is plus. So let us still create some bracket here and have this simplified to one number, and that is negative 2, and this is I. So lastly, we have to open up this bracket to obtain our answer as 7 minus, because positive times negative is negative. So we have here 2 and our I as the complex number given. So therefore, when we add Z1 and Z2, what we get here is the result we have just written here. I've just gone a little bit into detail for us to really know exactly how the complex numbers are added together. Otherwise, you can just work it even in one step and finally your answer. So let's move on to the next part, and that is part B of the question that says we also have to subtract Z2 away from Z1. So we have Z1 minus Z2. This must be equivalent to 3 plus 2i minus Z2 is 4 minus 4i. Now remember, you have to be so much comfortable with signs. If you multiply negative times negative, we know we get positive. Then negative multiplies by positive, we get, we need to give some equal sign here. This must give us negative. The reverse is true. If you have positive times negative, you should also get negative. And if you divide negative by a negative, you should get positive. If you divide positive by a negative, you should get a negative. And the reverse is also true. Negative divided by positive will give you still negative. So please feel free and get yourself comfortable with this sign in order for you not to mess up while adding or subtracting complex numbers. So let's go ahead and open up this bracket. So the first one has no effect, so just simply copy our 3 plus 2i, and opening up this is like multiplying negative and positive, going back to negative. So we have here 4, and negative times negative is positive, so we have here 4i. Collecting the real parts together, we have 3 minus 4, and also grouping the imaginary parts together, we have plus 2i plus 4i. So simplifying the real part, we have negative 1, and here this simplifies to positive 6i. So when we subtract Z1 minus Z2, this is the result we get. I hope everything is well. If not, please leave a comment in the comment section. I'll get back to you to clarify that doubt. So let's move on to the next part, and that is question number 2. I prepared 3 questions for you here. Question number 2 is very brief. In question number 2, we're asked to simplify this complex number given by 1 plus 4i plus into bracket negative 2 minus 3i. So we can copy it down here and say 1 plus 4i plus negative 2 minus 3i. This will be equivalent to, now we can open up the brackets. The first 2 numbers in the first complex number remains unaffected because they're all positive, and here we can also open negative times positive is negative, so we have here minus 2. Still negative times positive is negative, we have here minus 3i. Grouping the real parts together, we have 1 minus 2. Then grouping the imaginary parts, we have 4i minus 3i. So simplifying the real part, we have negative 1. And simplifying the imaginary part, we have 1i. So it is advisable to write only I. Just like you cannot write alphabetical arrangement like 1a, 1b. It is so boring. That is the reason we don't need to write this one before I. So this is the solution for part 2. How to look at it? Is it really interesting? If it is, please give it a thumbs up and subscribe to the channel for you to be able to see more of these interesting videos. Now let's move to the last part of this question, and that is question number 3. Okay, in question number 3, it's similar to what we have done in question number 2. It says simplify 3i plus 2i minus negative 4 minus 2i. So when you study this carefully, we have 3 complex numbers being added together. Now the first one is only having the imaginary parts. The real part is 0. And the second one is also imaginary part. The real part is nowhere, and that is 0. and we're subtracting. The second one is a full complex number with the real part and imaginary part. So working it out is in the same way. We have our negative 3i. Let's first write the way it was written for us here, and we have 2i minus into negative 4 minus 2i. So here, this is equivalent of, we eliminate the brackets. Here we have negative 3i plus 2i, and here the negative here, open up this bracket and changing everything to positive because we have negatives here in the two numbers, the real number and the imaginary number. So we have here plus 4 and also plus 2i. So from there, what we have to do is to sum up all these numbers which are imaginary together. If you wish, you can first rearrange them, where we start with the real number first, and we have here 4. This simplifies to negative 1, and negative 1 plus 2i, we get just I. So everything simplifies to 4 minus I as the solution for the sum of all these three complex numbers together. And before you pen off, I have prepared some exercise for you here. You can go ahead and work it out and share your result in the comment section to see what answers you've gotten, to really show that you've understood our lesson. See you in the next video where we shall look at multiplication of complex numbers. Peace out.